Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. And students, today we are going to start with solution chapter, right? And today we are going to focus on solubility, Henry's law and Raoult's law, okay? So everybody, if you are ready for the class, then let me know in the chat box. Then please fill the chat box with the green heart so that I can also know that you are excited for the class. And I think I should also wear my spectacles. You know my thing, na, that ma'am, eyes are not working, right? My eyes are not working. They don't work, right? So let's start the class. Everybody ready? Very, very good evening. Hello, Hema, Ravi, Blessy, Harini, Priyan, Aishwarya, Hedy, Isbelia. Okay, so everyone ready, steady. Okay, so we are going to start the class, and very interestingly, every single topic we will do in detail, right? Don't worry about that, but you have to promise me one thing, right? That you will be here till the end of this session, because there is no benefit, guys, if you're just watching it for the starting. You're not lying to me, you're lying to yourself, right? So this is your test. If you can sit patiently for 1.5 hours, and these three topics, I promise you, you will cover. We will also cover previous year questions from these topics. I'll also give you homework, but for that you have to sit here patiently, and you also have to reply in the chat box whenever I ask you any question. Okay, and today's chapter is very interesting. Today's topics are very interesting because so many real life things we are going to talk about, like why there is one fish called doomsfish, right? Why doomsday fish, why is it out, right? In so many countries we can see that in the ocean, right? What is happening? Some fishes that were very like inside the ocean, they are coming out of the ocean. What is the reason behind that? Why your cold drinks, right, where you carbonated cold drinks, you want them to be under a very cold temperature, very low temperature, right? So all these things we are going to discuss about, right? But before that, students, to all my new students, right, I am Diksha Kaushal, your chemistry master teacher, and students, I have done BSc, MSc in chemistry and B.Ed, and I have 8+ years of experience of teaching NEET and JEE students, right? Now, let us talk about one very, very important thing, right, before this class. That is the IV SAT scholarship program that is currently going on. So in this, if you get good marks, this is especially for the droppers, because I know that you already have done ample of mock tests and so many. You have also given NEET 2025 exams, so you can easily get good marks in this IV SAT scholarship program. In this, you can avail up to 90% scholarship. And not only that, right, for the repeaters, we are also giving them 100% fees refund or guaranteed rank improvement. And very rare institutes provide that. And students, if you're looking that, ma'am, where's the institute, right? Where can I visit? Then students, in Bengaluru, we have JP Nagar. In JP Nagar, we have institute, that is Vedantu Learning Center. You can see the address here. This is the number. You can talk to the counselors, the teachers. And for the other students, you can see all over India where Vedantu offline centers are located. You can choose your nearby institute and go and visit that. And you can give your IV SAT scholarship program and avail that 90% of scholarship, right? Okay, so everybody, let us start with the class. Okay, so one is, first you tell me one thing. What is a solution? A solution is made up of two things, right? One is solute, other is solvent, right? So a solute is something which is, ma'am, if, okay, tell me one thing. If you have, this is water, right? And you're adding sugar crystals, right? What is the solute? Ma'am, solute will be sugar. Ma'am, solvent will be water. This is what the general concept that students get. But tell me one thing, if you have a plate full of sugar, you have a plate full of sugar, and you're adding just 1 tablespoon, you're adding one just tablespoon of water or 2 tablespoons of water. Now tell me, what is the solute, what is the solvent? Now you'll be like, that means it's not like always solid is the solute, always liquid is the solute. No, solute is something which is less in quantity. Okay, you have to understand solute by less in quantities, the quantity will be less, and solvent is something which is more in quantities. Solvent is something which is more in quantity. Like here you have water is less, so water is the solute and solvent is sugar, right? So the one which is less in quantity is solute, the one which is more in quantity is the solvent. And when you add solute and solvent, what do you get? A solution. Yes, very good, Roshni. The bigger one, the one in low in concentration, very good, Paki, Rehan, Ravi, awesome. So the one which is less in concentration. Now, ma'am, can there be one solute, one solvent? How do we choose? Now, always remember that there will always be only one solvent. Always there will be only one solvent, right? One solvent, solute can be 1, 2, 3, 4, 10, 20, 30. It's not possible, right? So many solutes you will have, right? But yes, if you talk about, yes, solute can be any number, but solvent will be only one in number. Right? Now, talking about the types of solutions, right? One solution is called binary solution. Binary, bi means two. That means here you will have total components will be two. One is solute, one is solvent. Solvent will always going to be one only. So binary solution is one is solute and one is solvent, right? For example, you have water. You're adding sugar into it. You are mixing it. Now what is that? That is a binary solution because only one solute you're adding, right? Now let us talk about ternary solution. In ternary solution, that is ternary, that correspond to 3. Now one solvent you will have, 2 solute you will have. Now any example in your daily life that you mix, right? In your daily life, what is the drink are you eating? Are you drinking, right? Daily life, in my opinion, that I daily drink is I mix curd, water, then sugar. That is a ternary solution. Why? Because I have water, then I am mixing curd, then I am mixing what? Sugar into it, right? So that is a ternary solution, right? So you can also say, ma'am, let's say, ma'am, we are adding water, right? We are adding water. We are mixing salt and sugar into it. That becomes your ORS that you purchase from the market. You can make it at home only, right? So that is what you can make daily, right? That is your ternary solution. Now there is a solution called quaternary solution. Quad. Can you tell me what do you mean by quad? What do you mean by quad? Very good, Rehan. What do you mean by quad, everybody? What do you mean by quad? Quad means 4, right? Quadruple, right? Quadratic equations, right? Quadrupled, that is 4, right? So that means here you will have one solvent and 3 solute. One solvent, 3 solute. One solvent, 3 solute. Any example? Any example? Any example? Do you love lemon water? How many of you love lemon water? I love lemon water, right? So here, what you're adding? Okay, you're like, okay, I have one lemon, right? Lemon juice. Then you will add what? Then you will add salt. Then you will add sugar, right? Then you will add sugar. Especially the heat is too much around the surroundings, so we have to drink lemon water daily basis, right? Vitamin C, that is very needed, right? So lemon, salt, sugar and water that you are adding. So tell me one thing, over here when you are making lemon water, right, what is the solvent that you have? What is the solvent that you have? What is the solvent in lemon water, guys? What is the solvent in lemon water? What is the maximum quantity? Do you like, ma'am, I take up a glass of water, ma'am, I mix 1 glass of lemon juice into it, ma'am, I have 10 lemons, I'll mix 10 lemon juice into and I'll drink it. No, you will die. That is very acidic, right? So you only mix 1 or half lemon. You mix just half or maybe 1 tablespoon of salt, half and 1 tablespoon of sugar, right? You don't mix 1 glass of sugar. You don't mix 1 glass of salt. 1 glass of water we mix. Water is maximum. That is the solvent. Yes. Now from here, right? I know this is the most ignored part, right? How many of you have ignored this, right? Whenever you study solution chapter, you're like, okay, who will ask this, right? But they can ask this question, right? Why? Because right now they are asking questions from the ignored part of NCERT as well. So every single thing is important for you, right, students? So here we are fixing the solvent, right? And by the solvent, we are naming the solution. If I say solvent is gas, then that is gaseous solution. If the solvent is liquid, it is a liquid solution. If the solvent is solid, it is a solid solution. Now let's talk about when you are, what is the solute you are adding? And what you need to understand here, the examples you should know, right? Okay, let's talk about this. Gas and gas, right? Gas and gas, the example is mixture of oxygen and nitrogen gases in the atmosphere, that is mixture of gas and gas, right? Then liquid and gas, right? How ma'am liquid is dissolved in a gas? Everybody, chloroform mixed with nitrogen gas. You take a lot of amount of nitrogen gas, you mix chloroform, that is one of the mixtures. Then you have solid in gas, right? That is camphor. Okay, tell me one property of camphor. How many of you know what is camphor? Kapoor, do you know, guys, what is kapoor? Sublimation. That one kapoor that we usually that are used in temples or even for aroma, for good aroma it is used, right? So camphor has a very good aroma, right? So it also kills insects outside, right? That's where you will see that in temples and all that. You will see camphor, right? Camphor, when you heat it, from solid to vapor, it is directly converted, right? So now when you mix camphor in nitrogen gas, right, that is called the gas in gas solution. Okay. Then gas in liquid, guys. Oxygen dissolved in water. Can you tell me any example of oxygen dissolved in water? Any example of oxygen dissolved in water? In the ocean, how many of you love beaches? Right? Beaches are very nice, no? So there is aquatic life as well. Aquatic life is not alien, right? They also have to survive. How you survive? How you survive? I am not talking about Shahid Kapoor or Kareena Kapoor. I am talking about Kapoor, camphor, right? Okay. So, tell me one thing. Oxygen dissolved in water. So, aquatic life is also have to live, na? Like you are surviving on oxygen. You have to inhale oxygen. These aquatic life also have to inhale oxygen. For that, oxygen is dissolved in the water in the ocean. That is called oxygen dissolved in the water, right? Then liquid and liquid, very simple. Okay, tell me what is this? What is this? Anyone of you? Let me see. How many of you are that? Not intelligent, right? Like totally, ma'am, we know everything. Ma'am, you asked us, ma'am, and we'll shoot the answer, ma'am. Right? Ethanol. What is ethanol? What is ethanol? DNA batch. Radha, you can text me on the Telegram channel, okay? I'll resolve the issue in the Telegram channel, okay? Yes. Now, students, tell me one thing. Ethanol dissolved in water. What is ethanol? Ethanol is alcohol that people drink, right? Alcohol. So that is dissolved in water, right? So that is your alcohol. Ethanol is alcohol. That is methanol people can't drink, right? Ethanol people can drink. Still, it's not good for health, but still they are drinking, right? So next is solid in liquid, right? Solid in liquid, you have anything, salt in water, sugar in water, glucose in water, anything in water, any solid thing, that is solid in liquid. Then you have solid solutions. Gas in solid, big amount of solid you have, you're adding a gas into it, right? That is very, very important thing. Can you tell me where you use this? Solution of hydrogen in palladium, right? In palladium. That is your H2PD. This you will use in organic chemistry, right? Organic chemistry, you will use catalytic hydrogenation. How it is done? Ma'am, this is a catalyst and H2 will work on the surface of catalyst, right? How it is done? By adding solution of hydrogen in palladium, right? Nickel, these things. These are the examples. Then you have liquid in solid, right? This is amalgam of mercury with sodium, right? Mercury is a liquid at room temperature. Sodium is a solid at room temperature, right? When you mix them, you will have a liquid dissolved in solid, right? Then you have solid in solid. alloys, all the alloys that we have, they are solid in solid, right? Okay. Yes, everybody. Now, let's do one question that was asked in NEET 2025, right? One question that was asked in NEET 2025, guys. As I told you, this topic was ignored by students, right? They were like, who is going to ask these kind of questions, right? But you know what? This thing is there in your class 9th as well. That's why I'm telling you again and again, the topics that you ignore, they are asking questions on those kind of topics. Now the topics are not standard, that this is the standard topic, you go and see, do only these topics. No, it will not work in 2026, guys. This has not worked in 2025. And still, I can say that yes, still the topics that I told, from their questions came, right? But still, it's unpredictable now, right? So you have to do everything right. So now here, if you see, the question were this is the, now they are asking you humidity, alloys, amalgams, smoke, right? What are these? Solid and solid, right? Liquid and gas, solid and gas. Guys, firstly, we know that alloys are solid and solid, right? So we can say C is 1. C is 1, C is 1, C is 1. This is eliminated, this is eliminated. Then you talk about, not C, it will be B is 1. Wait a minute, my mistake. It will be B is 1, right? So it will be B1, B1. So C and B are eliminated, right? Now you talk about what is smoke, what is amalgams. Amalgams we have just discussed. Amalgams are liquid in solid, right? Liquid in solid. That means amalgams are 4. C is 4. C is 4. C is 4 here as well. C is 4 here as well. Now you talk about humidity. What is humidity? Moisture in the air. Moisture is very less quantity. In the air, air is full gas, right? So that you can say liquid in gas, right? Liquid in gas. Liquid in gas is 2, right? And then what about this one? What is smoke? Smoke will be solid in the dust particles in the air. That is called solid in gas, right? So that is your smoke. So answer will be D is the correct answer, right? Okay. NEET 2025 question. You can see for yourself from this table they have asked question. Now tell me how many of you are repeaters and how many of you have genuinely ignored this topic, ignored this page, right? In your NEET 2025 journey, how many of you have never even looked at this page? They're like, okay, let's ignore this. How many of you are like that? Okay, it's nothing to be ashamed of that you have skipped this. Everyone has skipped one or the other things, right? What you need to learn is accept what you missed, accept what you need to improve on, right? Okay, now students, next is solubility. Now solubility is a very important topic, and from solubility, trust me that the questions that they can ask you, the variance of solubility with temperature, the variance of solubility with pressure, solubility of solids in liquids, solubility of gases in liquids, this you have to be pro in, right? So we will talk about all of them one by one. Firstly, we are going to talk about what exactly is solubility, right? Now give me one answer, right? Your mom is like, huh, so much cooking I do for you. Can't you bring a glass of water and mix some sugar into it? Like what you will reply to your mother? Like yes or no? You will say yes, I'll do, or you will be like, I can't do that. So you will be like, oh my god, my mom wants, like she's tired, I will do that, right? You will go and you'll just pick out the glass, you then put 1 tablespoon of sugar into it. Like, okay mom, you take this. Your mom will slap you. She'll be like, you have to mix it. You're just giving me, you're not even mixing it. You have to stir it, right? Now, what you're doing, what she's asking you to do, she's saying that you have to make the sugar dissolved in this liquid. Only then she can drink it. Otherwise, on the upper, you will have water, and in the bottom, you will have only sugar. So it's not there, no? So you need to mix it. So that is called solubility, right? That is the general definition of solubility in layman's language. What is solubility? Now let's see what a chemistry student. You are a chemistry student. You should know in the aspect of chemistry what is solubility, right? So what we decided that we will fix the solvent. We'll fix the solvent as 100 gram, right? We'll fix the solvent as 100 gram, and we will see in 100 grams how much amount of solute is being dissolved. That is called the solubility. In 100 gram of water, how much sugar can be dissolved? That is called the solubility of the water. In 100 gram of, let's say, milk, how much amount of sugar can be dissolved? That is called the solubility of the sugar in the milk, right? Got it? Now, one thing you should know is that is like dissolved like in the case of solubility. That means this concept, just read out this concept for now. We will use this concept more in inorganic chemistry and organic chemistry. That is, in solubility, polar compound will be attracted towards polar. What is a polar compound? That has polarity. Like this is positive, this is negative. Those who do have no idea on polarity, don't worry. We'll discuss about polarity in inorganic chemistry, right? Now, polar will dissolve polar, non-polar will dissolve non-polar only, right? That is called solubility concept, right? Now, once you know like dissolve like, what I told you here, this is very, very important for you to understand, right? Very, very important. The concept of dissolution and crystallization. So everybody focus here for next 3 minutes, right? Full focus should be here. Full entire focus should be on the board, right? So let's see this, okay? Understand, try to understand. Now, there is a guy called Chintu, okay? There is a guy called Chintu because my students call me Chintu ma'am, right? So there's a guy called Chintu, right? Chintu be like, huh, I have to study. Chintu just wake up in the morning. He was like, oh my God, I have to study. I have physics, chemistry, bio, like too much targets I have. So I have to study. Now let's say after 10 hours, Chintu be like, oh my God, I have completed my target, right? Now, if Diksha ma'am be like, Chintu, you have to study more. Chintu, you have to study more. Chintu, study, Chintu, study. Chintu will be like, ma'am, but I have already studied for 10 hours, ma'am. I can't study more, ma'am. Already, ma'am, I have done 3-4 topics, ma'am. Practice questions, so much I have done. Now, what will happen? Chintu will become sad, right? Chintu will become sad here. Oh, Chintu will become sad here. Tell me why. Tell me why. Because what is happening here? Chintu was already in the saturation point. Chintu was already like, I am not able to study more. Diksha will be like, you have to study more. Then what will happen? Chintu, as he is studying more, right? What will happen? His saturation point has reached. He's like, I can't study more. Whenever I am studying more, everything that I have learned in the morning, I am forgetting everything. This happens with you, na? So when you study more than your capacity is, let's say you have targeted 12 hours, right? That's too much, right? You have studied for 10 or 12 hours. If I ask you to study more, but you have reached your saturation point where you can't study more, you'll be like, ma'am, if you forcefully make me study, I'll forget everything that I have studied in the morning, right? This happens with you or not? Let me know in the chat box, right? Have this ever happened to you, right? That, ma'am, as I am studying more, I am forgetting everything that I have studied before, right? That is what we will study as dissolution and crystallization, okay? Let's see that. So here, what we are going to study is, right, that you have this thing. Only one student has gone through that. Only Hema. Harini, better be interactive, okay? There is no point of me teaching you like this, okay? Then I'll be only able to teach you for like 5 days or 6 days. After that, I will also give up, right? So if you're here, when I ask you any question, I am not asking that be active throughout the session. I am just asking you, when I ask you some question, right? If you respect me, you have to tell me. Otherwise, what will happen? I'll start putting recorded versions only, right? You have any doubt, I will not answer in the recorded version, no? So there is no benefit of that, right? Okay. So now if you see this here, right, this is a beaker, right? And you dissolve water, right? You are added water into it. You added water into it, you added water, right? Now, I am asking that you dissolve some sugar crystals, okay? Let's say you are dissolving some sugar crystals. You're dissolving, you added some sugar crystals, right? Now you're mixing it. They all will be dissolved, right? They all will be dissolved. You're adding one more tablespoon, right? One more tablespoon, right? Then again you stir it, mix it, and again it will be dissolved. Again you added third tablespoon, 1, 2, third tablespoon you added some crystals, right? Now, what you observed here, that only some amount of, maybe half spoon of it was being dissolved, some amount of it is undissolved in the bottom, right? That means its saturation has achieved. It cannot dissolve more sugar into it. More sugar we can't dissolve into it. Now, if you can't dissolve more sugar into it, you will say, ma'am, that means the process of dissolution has stopped. That will only occur to your mind, na? That means the process of dissolution has stopped. But in reality, what if I tell you the process of dissolution has not stopped, right? The process of dissolution has not stopped. In reality, what is happening? Let's say these are the crystals that were being dissolved. Let's say these are also being dissolved. Now you're adding some more crystals. I am mentioning it by pink dots, right? Pink dot is your new sugar crystals that you are about to dissolve, and white dot is your old sugar crystal, right? Now let's say 2 tablespoons you added. Now when you added the third tablespoon, it is not getting dissolved. It is half of it is getting dissolved, right? Let's say this much is getting dissolved. So in reality, let's say third spoon I am mentioning by the undissolved particles, I am mentioning by this, okay? These are the undissolved particles, right? So you are thinking that the new sugar crystals that it cannot dissolve are undissolved only. But in reality, the same that has happened with you. That you are understanding the new concept, but the old concept is vanishing out of your mind. Same thing is happening here, that it is able to dissolve this new crystal, but if it dissolves one new crystal, one old crystal will reappear, right? One old crystal will reappear. Let's say it is able to dissolve one more crystal here, then one more old crystal will reappear, right? Let's say it is able to dissolve one more old crystal, new crystal, then one more old crystal will reappear. So that is called crystallization. So it's not like it is not, the new crystals are not getting dissolved. The problem is that as soon as one new crystal is getting dissolved, one old crystal is getting crystallized here, right? Opposite process is going on. That means when you observe that there is no more sugar that I can dissolve here, it's not like no more sugar can be dissolved. The problem is that you are not able to maintain the balance here. If new sugar is getting dissolved, the old sugar is getting crystallized here. Is that concept clear to everybody here or not? Right, students? That means the one thing that you have observed in crystallization, the one thing that you have observed not in crystallization, in equilibrium, that is, there is a dynamic equilibrium that it has achieved. That means the number of sugar crystals that are getting dissolved is equal to the number of already dissolved sugar crystals getting crystallized. What I am saying, that the rate of new sugar crystals, new sugar dissolved is equal to rate of old crystal being crystallized. That is a concept mentioned in your NCERT, right? Okay, students, that is clear. Okay, now this thing has occurred after it has achieved the saturation point. After achieving saturation point, this you can say that after saturation point. After saturation point, that means when no more solute can be dissolved. When no more solute can be dissolved. That was a very, very important concept for you, that dissolution and crystallization will become equal. Yes, what is a saturated solution? When no more solute can be dissolved at the same temperature and pressure, that is called saturated solution. Right? Now, students will talk about two things here. One is solid in liquid, other is gas in liquids. Okay. So let's talk about solids in liquids. Okay. Whenever I talk about solids in liquid, what you have to keep in mind, that you have a water and you have a glass of water and you're adding sugar, 1 tablespoon of or 2 tablespoon of sugar into it, depending upon how much sweetness you like. Right. So here, sugary solution we are going to talk about. Right. Asha, tell me one thing. If you want to add, okay, how many of you have eaten gulab jamun? How many of you have eaten gulab jamun? Right? How many of you love gulab jamun? Rasgulla, right? All these things, what they have a very thick solution of sugar. What is that thick solution of sugar? That is nothing but in water. You add one, we know that when you add 1 tablespoon of water, then you add 2 tablespoons. At third or fourth tablespoon, at least the water will be like, I can't dissolve more sugar into it. Right? Then what you have to do? You have to increase the temperature. This is what you do. You increase the temperature. Right? Now, when you increase the temperature, why you have to increase the temperature? Tell me in this. Why you have to increase the temperature? Why while making that thing, right, you have to increase the temperature? Because when you increase the temperature, molecules kinetic energy increases, and that is the reason. This also depends on two things, right? So when you're dissolving the sugar crystal, because molecule kinetic energy is increasing, right, at this point, so it will the solubility will increase, more sugar you can dissolve into it, right? But here is a very important point into it. That also depends upon the process that you are doing, right? Is that an exothermic process? Is it an endothermic process? That also depends on that particular thing. You can't blindly say solubility will increase or decrease in case of solids in liquids, right? Okay, how many of you know this? If you don't know this, you can watch my equilibrium chapter, which if you want to see the one shot, that will also be available. But if you want to see like part by part equilibrium chapter, that I'll take up for class 11th at 6 p.m. right? It will take around 1 month to get into this equilibrium chapter. But still, if you want to see equilibrium, you just want to brush it up, you can see my last year one shots. Okay. Now, equilibrium, we have studied that by a equation was there, where we have studied equilibrium is, if you talk about endothermic and exothermic reaction, right? If you talk about endothermic and there was this exothermic reaction, right? Now, if you talk about an endothermic process, right? When you increase the temperature, Kc is going to increase or decrease, right? When you increase the temperature, Kc is going to increase or decrease, everybody. So I'm not talking about solubility, I'm just asking about equilibrium constant, like what is the relation between temperature and Kc. We know that as you increase the temperature, Kc will increase. That is, temperature is directly, you can also write it this way, it's directly proportional to Kc. Here temperature is inversely proportional to Kc. This we have done in equilibrium chapter. Okay. Those who have no idea about it, relax, we are going to do this. Don't worry about that. Right. Till now, if you don't remember equilibrium chapter, just remember this thing, that in equilibrium we studied an equation where we got the conclusion that for an endothermic reaction, as temperature increases, Kc will increase. As if it is an endothermic reaction. If it is an exothermic reaction, temperature increases, Kc will decrease. But here we are talking about solubility. Right? This also we have seen in ionic equilibrium, that this is Ksp. This is Ksp in case of solubility. Right? And Ksp is directly proportional to solubility. This also we have seen in what? This also we have seen in ionic equilibrium. If you don't remember that, it's okay. We are going to revise that. Right? Now, this we should know. Right? Now, if you talk about an endothermic reaction, when you increase the temperature, solubility should increase. But if you talk about an exothermic reaction, which is going to release heat, in that case, solubility should decrease as you increase the temperature. Now, ma'am, who will tell me this is exothermic, this is endothermic? Like combustion reactions you have. Like combustion reactions are a different concept. For example, you are adding something. Have you seen, okay, if you add, you have acid and you add water into it. Tell me it is an exothermic reaction or endothermic reaction. Heat is released. Okay. Have you seen that when you have, like, okay, tell me one thing. For example, your mom is cooking pakoras for you. She's frying something for you, right? So she's making chicken or something like what you love. You can imagine that, right? She's frying something for you, right? By chance, even one droplet of water you add, what happens? Just one droplet of water you put there. By chance, by mistake, what happens? What happens? The oil will start dancing, isn't it? The oil will start dancing. So that means it is a exothermic reaction. So that is an exothermic reaction where heat is released, right? When you add acid into water, that is also an exothermic reaction. What is an endothermic reaction? So now I have glass, I am adding sugar, right? There is no like, oh, I have added sugar, oh my god, just be aware of that, oh my god, there will be a blast. Nothing like that happens. Otherwise, you would have never mixed sugar for your mother, right? Your mom is only cooking for you, frying for you, right? So this is glass and you're adding sugar into it, you're mixing it. That means heat is required. They're like, hey, water is like, hey, give me heat, I need to mix it. So heat is required. Whenever heat is required, that is an endothermic reaction. So that's why for when you're mixing sugar into water, as you increase the temperature, the solubility increases. Is that clear to everybody? Is that clear to everybody? Now, why I am telling you with the help of relatable things that you have seen in your house, right? So that way you can understand what exactly is chemistry, because this chapter is like completely related to what you see, what you do in on daily basis, right? Okay, cleared everybody? Everybody clear? Now, tell me what about effect of pressure? Okay, solid, 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 solid. This is a solid. Ma'am, please compress it. Ma'am, please compress it. I can't compress it. Solids are incompressible. So it's not like you will increase the pressure, solid will compress and they will mix faster. No, nothing is going to happen with the solid, right? That's why there is no effect of pressure in case of solid in a liquid. No increase, decrease in solubility is there because you have solid which is going to be mixed, right? Okay. Now, let's talk about solubility of gas and liquid. Okay, solubility of gas and liquid. Okay, gas particles are moving away, 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 right? They are not talking to each other. They are far away from each other. Now, tell me one thing. Can you give me an example of this? Let me see who can give me example of this from your daily life. What is the thing you love? You're like, oh my God, please give me that. But you are looking for that in fridge. You're looking that everywhere in your home. But your mom is like, I have to hide it somewhere, right? What is that thing? Yes? Ma'am, is solid or gas tolerate under high pressure? Solid or gas? No, no. Solid, when you have high pressure, right, it is incompressible. Obviously, it's not like if you have a big machine over there, right, and you are compressing some solid, obviously it will break, but it will not compress. It will break, right? So, and if you talk about gas, you can liquefy it also. You can convert it into liquid by compressing, right? Yes. So that is cold drinks. 7-Up. You love 7-Up. My favorite is Fanta. What's your favorite? My favorite is Fanta, but I try to avoid it because it's not Fanta what you're drinking. It's not Coke what you're drinking. It's not, these are basically carbonated drinks what you're having, right? And it's full of sugar, right? So you should avoid it, but definitely we are addictive to it, right? So once in a while it's okay, but on daily basis, I think as much as you can like skip this, that will be great for your health, right? Now, if you see this, students, what is exactly that? That is carbon dioxide under very high pressure. Okay, tell me one thing. If this is your Coke bottle, right? I don't have Coke bottle at my home, otherwise I would have shown you the demo, right? If I bring it at home, I'll have to drink it, right? That's why I avoid it. I don't keep it at home only, right? So if you like shake it, what will happen? Like water, nothing is happening here. What it will have a lot of bubbles. And what are these bubbles? These bubbles are of carbon dioxide, right? These bubbles are of carbon dioxide. So carbon dioxide is dissolved under very, very high pressure. That is called gas in liquid, right? Tell me one thing. If you increase the pressure more, what will happen? Gas is compressible. When gas molecules are far away, see, solid molecules are already very near to each other. Right? You can't compress them more, right? But gas particles are far away from each other. You can compress them. You can compress them. So when you compress the gas molecules, they will come closer to each other. And what is solubility? When you're talking to each other, when molecules are like more friendly with each other, that is solubility, right? So when molecules are far away, they are not talking to each other. When you put pressure, you put weight, right? The molecules are more closer to each other. The solubility will increase, right? So as you increase the pressure, solubility of gas increases with increase in pressure. You can say as pressure increases, solubility will increase. Okay, yes, okay. Now, I'm energetic, that's great. When I see you guys there, right, you guys are chatting, you guys are there responding, right, then my energy is automatically high, right? If you would have been like, okay, ma'am, whatever you're teaching, we don't care, then my energy will automatically drop, right? It totally depends on you, right? What is going to be my level of energy in the class, that is directly proportional to the energy of students, right? Okay. So in between, you can give me green hearts to level up more energy, right? So here, and yes, you can also like this button. The like button is totally free of cost, no cost for that. Do like that so that I can get more motivation to provide more good content to you, right? Okay. Now, temperature. Tell me one thing. Some guests are coming to your home, right? Science like, mom, guests are at home. Mom be like, okay, do one thing. You have Coca-Cola in the fridge. Heat it and give to the guest. Like, mom, are you like serious? Like, I have to increase the temperature of Coca-Cola. I have to give them warm Coca-Cola. Like, ma'am, like, mom, why? Why I have to do that? Your mom be like, no, it's good that way only. No, right? You don't do that. Or do you do that? It's like, ma'am, I do that so that guests never come back to my home. Right? So we never do that. Instead, what we say, oh, you have a cold drink, right? It is named as cold drink only, right? You have a very low temperature, we try to keep it. Do you ever enjoy cold drinks or carbonated drinks? You bring up 7-Up like from the market, it is hot and you're drinking it. No, you'll be like, okay, I can wait for 30 minutes. I need to keep it in the fridge. Why? Tell me why. Because, right? Tell me. Why? Because solubility of the gas, when you increase the temperature, molecules are moving away. Their kinetic energy increases. And in case of gases and liquid, there is no endothermic, exothermic in this case. Always it is going to be the same. That gases, as you increase the temperature, the particles will move away from each other. That's why solubility will decrease. So when you increase the temperature, solubility will decrease, right? Can I give you a real life example for that? So how many of you have heard that I won't say that that is a news, right? That is a misconception, right? That most of you must have heard about that in Japan also. I don't know what are the other countries, but I think in Tamil Nadu or Kerala also, right? Doomsday fish, right? That was observed, and some dolphins were also observed, isn't it? Right? Am I quoting it right? If I'm wrong somewhere, you can always correct me in that, because I don't clearly remember that, right? But there was something like that was going on in the news, right? So can you tell me, like, is it a God signal to what? Like doomsday is coming or what? Is it that? No, you're a science student, right? You have to find logic behind everything. The logic is that we are under that zone where we are doing a lot of global warming, right? The temperature of our earth is increasing, the glaciers are melting, right? You must have seen that the temperature, right, it has increased to next level, right? Where I live, the temperature is currently like in the afternoon, the temperature was 43 degrees, 44 degrees, very normal. You can't step out of your home, right? Like kudos to those people, like hats off to those people, not kudos, hats off to those people, laborers who are working at this, like, you know, they are working under such high temperature. Like, I don't know, like they are seriously hats off to them, right? So what I want to tell you here is the temperature is increasing, right? So what is the temperature in your city? In the afternoon, what was the temperature in your city? Any idea? Any idea? So guys, okay, bye bye. So here, because of global warming is increasing, right? Temperature is increasing. Ocean temperature is also increasing. Sea level, sea temperature is also increasing. That means the temperature, I told you one thing, that oxygen is dissolved in the oxygen is dissolved in the water of the ocean, right? Because temperature is increasing, global warming is increasing, temperature is increasing, solubility of oxygen in ocean water decreases. That is why what is happening here, the fishes that were very inside the ocean, they are coming out of the ocean because they also have to inhale oxygen, right? But because of very high temperature that is impacting the ocean as well, they are coming out of the ocean. That is the real reason behind that, right? Okay, that is the real reason behind that. Now if someone asks you, you have a proper logic for that, and when you have logics, you are more confident in the conversations, right? Isn't it? So you can also teach your parents about this, that what exactly is happening in the universe, in this world, what we are doing, right? Okay, now let us see this question here. That is, the solubility of a substance is 40 at 25 degrees Celsius. This means the solution is unsaturated, saturated, supersaturated, or none of them. Yes, students, the solution is solubility. So whenever it is given 40 at 25, that means 40 gram of solute is dissolved in 100 gram of water. In 100 gram of water. So you can say already the solute is being dissolved. Maximum solubility can be this much. That means it is a saturated solution. No more solute can be dissolved into it. So answer will be, it is a saturated solution. Okay. Let's do the next question here. That is the solubility. Now what is given to us? The solubility of a substance in water is 40, right? The solubility of a substance in water is 40. What is the maximum amount of solute required to prepare a saturated solution of 50 gram of water? Okay. Now students, if you see this here, what we are going to say is 40 solubility means 40 gram of solute in 100 gram of water, right? 50 gram of solute in 100 gram of water, right? So can I say that for 50 gram of water, what will be the answer? That means 20 gram of solute in 50 gram of water, right? So answer will be 4, that is 20 gram is the correct answer, right? Okay, thank you, Paki. Is that clear to everybody? What is very hard to understand, beta? What is very hard? You can tell me. Right, 40 gram of solute in 100 gram. Apply unitary method. That means divided by 2, 20 gram in 50 gram. Okay, understood? Yes. Okay. Now, this I'll teach you after Henry's law. Firstly, let's do Henry's law. Okay, but Henry's law also we have to do this again. Chalo, let's firstly understand vapor pressure and partial pressure. Okay, let's understand the difference between vapor pressure and partial pressure. Those of you who know what is vapor pressure, solubility we have completed. Now two topics were left with. One is one is Henry's law, other is Raoult's law. Okay. Now who will tell me what is the difference between vapor pressure and partial pressure? Let's see who knows, right? Okay. Okay. Yes. Yes. Don't worry, beta. If you're like understanding this for the first time and you're finding it hard, don't worry. You have recorded version of this will be there on the channel only. You can re-watch this. That is the best thing that you can do. Right? Okay? Yes. But now try to have focus, right? See one thing. Whenever we talk about volatile compounds, tell me what are the volatile compound? The one which is able to form vapor. Right? Okay, the one which is able to form vapor. Sharu is saying partial pressure is the pressure of particular gas in a mixture. Liquid turns to gas, it is called vapor pressure. Vapor pressure is the pressure of one gas at vapor state above the liquid surface. Okay, great. Great. That means you know something. Okay, let's clear everything today. Right? Students, see, let's say you have a beaker. It is volatile. That means it is making vapors. Right? So what will happen? Those vapors are going to put pressure on the liquid. That is called vapor pressure. Okay, that is called vapor pressure. Right? I think Paki has given the right definition of vapor pressure. In general, what is vapor pressure? But now understand, you know, in your entire solution chapter, you will see one is P naught and one is P. This we denote by vapor pressure and this we denote by partial pressure, right? But ma'am, who will tell me what is P naught, what is P? They will not directly give this is a vapor pressure of pure substance, this is partial pressure. How you will understand from by reading the statement only, okay? Let's see that. Students, what you have to understand here is you have a beaker. It is making vapors, okay? It is making vapors. Let's see, it is making these vapors. Okay, it is making these vapors. You have another beaker. It is making these vapors. Okay, now see one thing. This is you, this is Chintu studying alone, this is Mintu studying alone, right? Chintu who is studying alone, Mintu who is studying alone. Chintu, when he is studying alone, right, he is putting vapor pressure in the pure state, right? That is denoted by P naught A and this is denoted by P naught B. When the vapors are putting the pressure, but in this case, there is a pure liquid. So when the vapors of the pure liquid are putting pressure on that liquid, that is called vapor pressure of pure liquid, right? That is denoted by this naught. Is that thing clear to everybody? What exactly is vapor pressure in the pure state? That is denoted by this naught. Naught means this zero, right? This is denoted by this naught, right? Now, one more thing that you will see is PA and PB. What is this PA and PB? Everybody, what is this PA and PB? See one thing. If you talk about this PA and this is PB, one thing you should understand here, that these are the vapors, right, of the mixture. I have mixed A and B. I have a new solution that is green in color. This is the solution. Now, what is happening here? Some vapors of A you have here. Okay. Some vapors of B you have here. Right? Both of them are putting pressure. Right? It's like you were studying alone and your friend is studying alone, right? Now you both are put into a room, like you have to study together, right? Now you will talk to each other, right? That means your amount of focus will definitely change, right? So now this is the pressure, same thing, the vapor pressure that these vapors are putting on the liquid, but when they are in the mixture state. When we mix two liquids and then their vapor pressure is putting the pressure, that is called partial pressure. Partial pressure means in parts, right? Partial pressure of A and partial pressure of B. Now let me know in the chat box if that is clear to you. What is P naught A, what is PA, what is P naught B, what is PB, right? Okay, total pressure will be equal to that. We will talk about in Raoult's law as well. Total pressure is equals to PA plus PB. This is basically Raoult's law only that we will discuss. Don't worry. Firstly, let's discuss Henry's law. Okay, understood? Everybody clear? Right? But if that is clear to everybody, then let me know in the chat box if P naught A, P naught B, PA and PB is clear to everybody here, right? What you're not able to understand also let me know that, right? So that I can help you. The difference between partial pressure and pressure of, okay, see one thing. This is the pressure of the vapors on the liquid when you have a pure liquid A. This is the pressure of the vapors of B when you have a pure liquid B. And here you are mixing two things. Then what is the pressure of A vapors on the liquid? What is the pressure of B on the liquid? That is called the partial pressure. It's like the same situation when you're sitting alone and you're studying. That is P naught A, right? But when you're with your friend in a group and you're trying to study in the mixture, that definitely your study amount will change, right? Because you will talk to them, right? You will gossip, right? This and that. So that will change. That is called partial pressure. Okay? Got it? Yes? Okay, great. Now, let us see partial pressure we have done. Now, bacha, let's talk about mole fraction, and mole fraction are also of two types, okay? Mole fraction are also of two types, okay? That you should remember. Wait a minute. I think, yes. Okay, mole fraction are also of two types. Just give me a minute. Yes, that will be here. Chal. Understand firstly one thing, we are going to talk about both the mole fractions, okay? Now, beta, see one thing, you have this liquid. This is the liquid that you have, right? Now, it is forming some vapors. Okay? It is forming some vapors. Now, let's talk about mole fraction, right? One thing is called mole fraction in liquid phase. That means the mole fraction that is there in the liquid phase, that means in this liquid phase, what is the mole fraction? I'll give you the definition of mole fraction. Just understand what is liquid phase and vapor phase. Liquid phase means this mole fraction we are talking about, that is represented by this X kind of symbol, right? And when we are talking about mole fraction in vapor phase, that means we are talking about this mole fraction that is represented by Y. Understood? Two mole fractions are there. One is mole fraction in liquid phase, one is mole fraction in vapor phase. Mole fraction in liquid phase is represented by this, mole fraction in vapor phase is represented by this Y. Right? Now, in Henry's law, we talk about mole fraction in liquid phase. Okay, we don't talk about mole fraction in the vapor phase. Right? So now, let's talk about mole fraction. The definition of mole fraction is simple. That mole fraction is of that component is equal to this. I have also taught you in the previous lecture, that is concentration terms, right? You can check that out. We have also solved questions based on that, right? So mole fraction is equals to number of moles of that component divided by total number of moles that we have discussed in the concentration terms, right? Now, if you see this here, you know the mole fraction in Henry's law, we talk about mole fraction in the liquid phase, right? Here, I told you one thing, when you increase the pressure, the solubility will increase. Have I told you that? Gases and liquids, as you increase the pressure, solubility will increase, right? Now, Henry said that, okay, solubility, you can also calculate this in terms of mole fraction. So, he said that as you increase the pressure, mole fraction will increase. That means pressure is directly proportional to mole fraction, right? Now, after replacing the proportionality sign with Henry's constant, we have this. Let's say we are talking about some A component here. Partial pressure of that A gas is equals to kH multiplied by the mole fraction of A in the liquid phase. That is called the Henry's constant. That is called the Henry's law. Is that clear to everybody? What is Henry's law? He said that pressure is directly proportional to solubility. Solubility we can measure by mole fraction, right? So that means it is directly proportional. After replacing the solubility, you have, after replacing the proportionality sign, you have KH. That is the Henry's constant. So solubility of the gas in liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid, right? Okay, partial pressure above the surface of the liquid. Now we can see this is comparable with y is equals to mx. But tell me, till here everything is clear, no? Y is equals to mx plus c, right? Y is equals to mx plus c. This y is the partial pressure. Can you see that y is the partial pressure? Y is the partial pressure. X is the mole fraction. You can see partial pressure is the y-axis, right? Mole fraction is the x-axis, and m is the slope that is coming out to be kh. So slope will be kh, and intercept here is 0. Intercept here is 0. That's why this graph is starting from origin, right? Any problem till here? Any problem till here, students? Any problem till here? Chapter this, ma'am, like classes for, but we also take live classes for class 11th at 6 p.m. Okay, class 11 we teach at 6 p.m. and class 12 we teach at 8 p.m. right? So you can watch the lectures there. Okay, that you don't need to worry about. Okay, yes. Shall I stop asking you if that is clear or not? Shall I stop that? You let me know. Shall I stop caring about you? Shall I stop asking you? Shall I not be bothered about you? Right? If that is so, if you are so habitual of that thing, I'll do that only, but it's very difficult for me to do that because that's not what I am. Right? Tell me. Shall I stop asking you if that is clear? Shall I stop putting the energy? Shall I stop putting the efforts for you? Hanji? Shall I stop that? Now I will not, this marker, I am putting it here, right? And I'm going to end the class if I don't see you guys interacting here. It's as simple, right? I can't teach like this, beta. That's not me, right? I can't teach like that. Seriously, that's too much, right? So you can go and see the Raoult. So there are multiple videos that are provided to you on YouTube. I know the education is provided by multiple channels out there, right? Maybe you don't need me. It's totally fine, right? Okay, chalo, bye bye. I don't know why you all have to spoil my mood like that. I don't understand. Such a beautiful lecture was going on, huh? Energy was high, everything was good. Manu, now you can say, yes, ma'am, please don't stop. But when I was asking you question, then you had no answer. Aishwarya, same applies to you, right? Everything else is not interested. Is it? Okay, so this is your Henry's law, that is P is equals to KH multiplied by mole fraction. This KH is the Henry's constant, this X is the mole fraction here, and that mole fraction is in the liquid phase, not in the vapor phase. That you have to understand, right? Now, next thing is that if you talk about the applications, first application is the hypoxia. So what is hypoxia, or you can also say that is called anoxia. What is this anoxia? So what happens is when you go out in the clouds, right? That not in the clouds, you can say in very high altitudes, what happens? The pressure decreases. Because pressure is decreasing here, that's why solubility will also decrease, right? Now that is the reason, right? It is very suffocating for the people who are out there in the higher altitudes to survive actually, and that is the reason, right? You will also see if you take up a lace packet, right, and it start to uh, get more fluffy when you move out in the mountains, right? What is the reason behind that? Because pressure is decreasing, and inside pressure is more, outside pressure is decreasing. That's the reason it will burst out. That means that lace packet or any packet you carry out, that will be more fluffy, right? Okay, so that is the first application. Second application is Acha, you have just gone out for 2 minutes, then it's okay, man. Then it's okay, then I apologize for that, right? Then there is scuba diving. Scuba divers. So now if you understand that scuba divers means the one that go inside the ocean, right? So inside the ocean, what happens here, right? Inside the ocean, if you see, the pressure is very low, right? The pressure is very high, right? Inside the ocean, the pressure increases. That's why the solubility will also increase. And those scuba divers, they carry a cylinder with themselves, right? In that cylinder, they have oxygen gas, right? They have nitrogen gas dissolved in it, right? Now, what happens is that when the solubility is more, the oxygen, our bloodstream, you know it very well, that in our bloodstream, blood carries oxygen. That means oxygen is more soluble in the blood when you go inside the ocean, right? But when the scuba divers come out of the ocean, right, what happens, right? When they come out of the ocean, the pressure will decrease, right? Solubility will decrease. That accounts for a situation called bends, right? And in this bend situation, these veins, right, they, like, it's a very drastic situation, right, where people can even die, right? So that's why in that scuba diver cylinders, we not only mix oxygen, not only mix nitrogen, but also we mix helium. Why? Because it is a inert gas. We mix helium because it is a inert gas. Okay, helium is mixed because it is an inert gas. It will not be soluble in our bloodstream, so that can help us not to get bends, right? Okay, now let's talk about the next thing, that is carbonated drinks. We know that carbonated drinks are under very high pressure, right? That's why you have, whenever you drink cold drink or anything, you have something very freezy sound effect on your nose or on your mouth, right? Why you burp suddenly? Because their carbon dioxide is already in it, right? That makes you an illusion that something has been digested, but in reality, that is the carbon dioxide you have actually taken from the cold drink, right? Okay, now I have talked about mole fraction in the liquid phase. That was denoted by this symbol here. Now let's talk about mole fraction in the mole fraction in the vapor phase. That is denoted by Y. Now the formula is that Y, how you will calculate that? Y also having Na. Let's say I'm counting it for A. This will be Na by Na plus Nb. But ma'am, mole fraction also in the liquid phase is also, ma'am, same. This is also same. This is Na. This is Na plus Nb. Right? Now, I'll just erase this, not as Na. Instead, I'll write it as Ma. Right? Let's write it as Ma. This is Ma plus Mb. Because N is representing number of moles in liquid phase, and M is representing number of moles in vapor phase, right? that is representing number of moles in the vapor phase, right? That is the genuine definition. But if you talk about in reality here, if you talk about in reality, what is the formula that was given here? That was partial pressure is equal to mole fraction in vapor phase multiplied by the total pressure. That is going to be the formula that you should remember. Now I'll also tell you how to use this formula. Don't worry about that. Just remember this formula, partial. See, what was for mole fraction in liquid phase? That was partial pressure is equals to mole fraction multiplied by kH, right? And this is partial pressure is equals to mole fraction in vapor phase multiplied by total pressure. Right? Got it? Now let's see NEET 2024 question based on this. That is the Henry's law constant. Values of three gases are given to you. That is A, B, C in water are this, and this kilobar respectively. The solubility of these gases in water follow which order? Right? Solubility follows which order? Right? So they are saying the three gases, Henry's law is given to you, right? And we know that P is equals to KH multiplied by the solubility. If we take P as constant, right, then can we say that KH is inversely proportional to the solubility? That means more is the value of KH, less will be the value of solubility. So maximum value of KH will be there for this one. 145, that is for A, that will have the minimum solubility, right? Minimum solubility. Then you will have, maximum is for this one. Then you have 35, that is going to be C. Then you have B, that has the minimum value of KH, and that is going to have the maximum solubility here, right? Okay. So that's how you're going to answer this. Comparing these values, answer will be B is the correct answer. Okay, what you should remember, that just remember this, and what is inversely proportional here? That is your NEET 2024 question. Okay, now let's do the next thing, that is NEET 2022 question here, right? NEET 2022 question here, that is they have given KH value for some gases at the same temperature are given. The KH Henry's law constant in water, the order of solubility in water, again based on the same principle. This is the gas, this is the value of KH that is given to you, right? Solubility you have to tell here. We know that solubility is inversely proportional to KH. Okay, this we know that solubility is inversely proportional to KH, right? We know solubility inversely proportional to KH. Can I write here that if I talk about the maximum value of KH, maximum value of KH, that is going to be argon, that is going to have minimum solubility, minimum, this is eliminated, this is eliminated. Now let's search for the maximum value that is there for HCH only. You have to see after argon which has less KH value as compared to argon. After argon, you have CO2. So after argon, you will have CO2. Then you will have CH4, because this is in 10 raised per minus 5. That is minimum. 10 raised per minus 5 is minimum it can go. Minimum KH value means maximum solubility. That means answer is going to be B is the correct answer here. Answer is going to be B is the correct answer here. So we just mark the answer as B is the correct answer, and you got your +4 marks. Right? Okay, students? Got it? Now let us see the next question, everybody. Everybody, let's see the very good, very good, very good. Those who are answering, very good. Now let's talk about Raoult's law. Let's talk about Raoult's law. What is Raoult's law? See one thing. That I told you one thing, okay? I'll just pick up that slide and take it over here, okay? What I taught you, students, about partial and vapor pressure, right? Same thing we are going to discuss here, right? Regarding partial and vapor pressure. What I told you, that if you talk about, you have a pure liquid A, pure liquid B, this is putting the pressure P naught A, this is putting the pressure P naught B. When you mix them together, it will put the pressure PA, this will put the pressure PB. Now, what is the total pressure? Total pressure that you will put in that mixture is going to be PA plus PB, right? And what Raoult's law told you, that Raoult's law told that the partial pressure of any liquid in a mixture, let's say A, is equals to the vapor pressure of that liquid A in the pure state multiplied by the mole fraction of that liquid in the liquid phase, right? That means partial pressure of B in the mixture is equals to vapor pressure of B in the pure state liquid B multiplied by mole fraction of B in the liquid state. Okay. For a solution of volatile liquids that forms vapors, partial vapor pressure of each component of solution is directly proportional to mole fraction present in the solution, and that too in the liquid phase. Mole fraction in the liquid phase, right? So when you see this, you know that what is the value of PT now? PT will become PT is equals to PA plus PB, right? What is PA, guys? PA is P naught A, mole fraction of A, plus P naught B, mole fraction of B, right? This you know. Now let's solve it further, right? You have PT is equals to P naught A, mole fraction of A, plus P naught B, mole fraction of B, right? If you know one thing, mole fraction of all the components is equals to unity. That means you can put the value of mole fraction of A and you into 2B. You can do anything here. I am just putting the value like this. I am putting the value of mole fraction of A in terms of B. Right? 1 minus mole fraction of B plus P naught B mole fraction of B. Right? So you can keep it here. This will be P naught A minus P naught A mole fraction of B plus P naught B mole fraction of B. Take it common, P naught A plus take the common mole fraction of B plus mole fraction of B. Then it will be P naught B minus P naught A. That is going to be your answer for PT. Now you will see this is also the formula, this is also the equation of Raoult's law. This is also the equation of Raoult's law. Let me just mark it here. This is also the equation of Raoult's law. This is also the equation of Raoult's law, right? And if you see that, ma'am, if I do the opposite, ma'am, if I do the opposite, you will have opposite then. Okay. Let's say if you do the opposite. Okay. Let's say if you do the opposite, that means if you're like, ma'am, I'll put the value of PT, this is equals to P naught A. I'll put the value of mole fraction of B is 1 minus mole fraction of A, right? Now it will be P naught A mole fraction of A plus P naught B minus P naught B mole fraction of B. That it will correspond to PT equals to, you keep it in the same manner. Here you have put P naught A. Wait a minute. Here only you can take the common, no? Okay, here only you can take the common. Put P naught B. I have kept P naught B here. Plus of mole fraction of A is common between this and this. Wait a minute. This will be mole fraction of A. This and this is common. This will be P naught A minus P naught B. Okay. So what you have observed, I'll tell you a simple way of learning this. This is PT, P naught A. This is A. This is B. This is BA. What you have to remember? A, B, B, A. Okay. Otherwise, it will be B, A, A, B. This is B, A, A, B. And how the formula you're going to put? P naught plus mole fraction multiplied by P naught minus P naught. देखो बेटा, simple way I am telling you to write here. Okay, let's say I'm gonna write it here. PT is equals to P naught plus mole fraction P naught minus P naught. Again I am writing PT is equals to P naught plus mole fraction P naught minus P naught. Now what you just have to write here, if you're writing A firstly here, let's say you're writing A, then it will be AB, BA. If you're writing B here, BA, AB. Okay, this is the way, because they can also give you questions like which of the following is not representing Raoult's law. So instead of you have 180 minutes for 180 questions, right? So where you can save your time, you have to save your time there, right? Where you can get yourself rid of the calculations and all derivations, you need to do that, right? Okay, students, that is your Raoult's law. Let's see what is this. Now we will do in the tomorrow's class also. In the not tomorrow's class, in the next class we will talk about ideal, non-ideal solution, all of that, right? And in that class I'll discuss in detail about pressure and mole fraction graph, temperature and mole fraction graph. Okay, now if you see this here, right, this is your graph where what exactly we are telling that as you increase the, let's say, the mole fraction of 2, you are increasing. You increase the mole fraction of 2. Okay, let's see one thing. Okay, this is 1, this is 1. Here mole fraction of 2 is 0. Okay, so here you are increasing the mole fraction of 2. As you are increasing the mole fraction of 2, we know one thing, that the partial pressure is directly proportional to that. So partial pressure will also increase, because partial pressure is equals to mole fraction, is directly proportional. That's how you got this. Now here I am saying that the mole fraction of 1 is 0. That means corresponding to this, as you go to this side, the mole fraction of 1 is increasing, right? So here can I say that as you increase this, the partial pressure will increase. And when you add these two things, you will get the total pressure. This is the exact graph that they have drawn here. Okay, this is the significance of this graph, how it is related to the Raoult's law. Okay, and we know that PT is equals to P1 plus P2. P2 is equals to P naught 2 mole fraction of 2. P1 is equals to P naught 1 mole fraction of 1, and that's how you have this graph. And the solutions that follows Raoult's law are called ideal solution. The solutions that don't follow is called non-ideal solution. That we will discuss in the further lecture. Okay, let's see if you're able to do this question or not. A solution of two miscible liquids showing negative deviation from Raoult's law. Achha, wait a minute. This is actually not a question of this one, right? Okay, let's do the other question here. Yes, let's do this question, everybody. That is your AIPMT 2012 question. So guys, we are specially selecting questions from AIPMT, AIEEE, JEE also. I am taking up questions from JEE as well, right? So these questions, why we are taking, right? So that you get multiple practice questions from different exams, right? So that you can get an idea what is going to be there in NEET 2026, right? So now here the question is, vapor pressure of chloroform and dichloromethane at 25 degrees Celsius are this and this. Okay. Vapor pressure of solution obtained by mixing this much and this much at the same temperature will be total pressure. Okay, simple. Okay, see, they are asking you vapor pressure of the solution, that means PT, which is equals to PA plus PB, right? PA plus PB is nothing but it is P naught A plus P naught B. Oh, sorry, P naught A mole fraction of A plus P naught B mole fraction of B, right? Now students, if you see this here, this is the formula that you need to apply, right? That we got to know. But can you tell me one thing? What is P naught A? Because vapor pressure of chloroform and this is given to be 200, that means they are talking about pure vapor pressure. That means P naught of chloroform, that is P naught A. This is P naught of dichloromethane, that means this is P naught B. Can you solve the value of mole fraction of A and B? First, you tell me what is number of moles of A. Number of moles of A is chloroform, it is mass is given to be 25.5, molar mass is 199.5. If they don't give you, you should calculate. You should be able to calculate that, right? Now, what is number of moles of B? That is given to 40 gram and mass is 85. 40 gram and mass is 85, right? Now, what is the formula of mole fraction of A? That is Na divided by Na plus Nb, right? What is mole fraction of B? That is 1 minus mole fraction of A. 1 minus, or you know what you can do? You just calculate the mole fraction of A. Okay, let's write it in the mole fraction of A. What you have to write? P naught plus mole fraction P naught minus P naught. Write it in the form of mole fraction of A. That means this should be A. If this is A, this should be B. BA, AB. P naught A, P naught B is already given to you. Mole fraction of A you can calculate here and then put all of this in this equation and you will get your answer. Okay, students, put all these things in mole fraction of A here, P naught A given to you, P naught B given to you, and you will get your answer. If you get into solving the value of mole fraction of B, that will get more lengthy. In this way, it will be solved more easily for you, right? Okay, and after solving, you will get the value as 90.6 mm of Hg, right? And now I'm giving you two questions for your homework, right? That is, first question is, according to Raoult's law, what happens to the vapor pressure of solvent when non-volatile solute is added, right? Vapor pressure of solvent when non-volatile solute is added. That is the first question. And second is, Henry's law at constant pressure, right, states that solubility of gas in liquid is directly proportional, mole fraction of gas in solution is proportional, partial pressure of gas in vapor phase is proportional to the mole fraction, or all of these, right? Now you can just take the screenshot of this question and this question here, and I'll see how many of you are actually dedicated to solve the question by yourself and give me the answer in the comment section, right? Okay, you will get the notes in the description box, that will be provided in the description box, beta. Okay, and you can also just scan this scanner here. You will get to the Vedantu NEET English official Telegram channel, because that will help you to understand when are live classes, so that you will miss even a single lecture, right? Every important thing about NEET is going to be there on the Telegram channel. So you can go and subscribe to the channel. That will be very, very helpful for you. And students, I want you guys to write down your homework in the comment section. If you don't want me to see me like this, but I think most of you want me to see me cry, है ना? I think you won't. Or am I wrong? Then prove me wrong, right? Now, students, and for all the students who are looking for offline coachings, right? Then students, we have 90% scholarship that is going on right now if you crack IB SAT scholarship program, and this is especially for the repeaters and droppers, because students, we are providing you guaranteed rank improvement or otherwise 100% fees refund, and you can go and visit our JP Nagar Bengaluru center if you are living in Bengaluru, or you can also contact on the contact number here, or otherwise you can also visit, if you're not nearby Bengaluru, then you can visit our like various centers here. You can see, right, different centers that you can see here. You can visit these centers as well, right? Okay, students, and one very important thing for all of you, wait a minute, that is in the description box, students, if you see this here, right, in the description box over here, what you have to do is here, like, that is your DNA NEET batch for 2026 aspirants. Click here. When you click here, what you will be guided towards is NEET DNA batch, especially for droppers and repeaters. This is, right? So 12 students can also be enrolled to this, right? If you want to cover your backlogs, if you want to be NEET, basically this is for all the students who are preparing for NEET 2026, right? So now in this batch, what we provide you is the live classes. We provide you modules, tattva modules, DPPs, leaderboard is there, quizzes are there, mock tests are there, test series are provided to you. Mock test is provided, live mock test is taken after every 15 days. So all of these things are there in the batch. You can talk to the DNA students yourself and they will give you a good review on that, right? And students, many students are getting benefited out of this batch here. I would advise you to get enrolled to this batch to maintain the consistency of the lecture. And like here I have to ask again and again, are you able to like understand or not? There I don't have to ask. Students are very active there. It is like highly disciplined lecture. You will see how your competitors are so much active, right, in the chats. And even I have the option of making the chats private. So sometimes I make the chats private, right, so that they don't see each other's chat. When I have to make them compete with each other, then I make the chats public. So it is like that, right? We have hotspots where we can ask you, like here you have to type yes, yes, yes again and again. There the hotspot, you can directly answer if there is any doubt or not. And there is a class teacher also who will answer your doubts in the class if you have any doubts left. And even the replay version, you can ask your doubts. So these are all the features of the DNA batch. Click on the link, you will get to this portal. Then just click on view course plans. And this is like different course plans of DNA batch, where if you want to have a 5999, this is NEET quick revision cards are also provided to you. Basically, these are the short notes that are provided to you. These are the quick revision cards. Like I want to study concentration terms that are given on this page and this page. That's it. I just have to carry this and I can do concentration terms by walking in the garden or something, right? So these are the quick revision cards that we have. You can see this here, right? Okay, these are for your Bohr models. This is your emission spectra. Okay, all these things are there in the quick revision cards. In that, it will be 5999. And if you want to get QR cards plus AITS, All India Test Series, it is provided in the batch. But that is the online test series. If you want to get the hard copy of test series, then that will be for 6999. So according to your choice, you can plan what you want to purchase, right? Okay, students. So guys, that's it. That's it for today. Wait a minute. Wait a minute. Okay, students. So that's it for today. Now I'll just take your leave. Bye-bye. Take care and all the best for all of you, right? And don't forget to like this video, right? Very few likes you giving, right? I don't know what you want, right? You want like what, right? You want pure content that we are providing you. Top-notch content that we are providing you. Full energy we are providing you. Homework we are providing you. All you have to do is like this and do also give your homework. Like do comment down your homework what I have given. Right? Okay. So that's it, students. Bye bye. Take care. See you all in the next class. Bye bye.